In the world of DevOps, package feeds play a crucial role in managing dependencies and distributing software components. A package feed is essentially a repository where packages are stored, versioned, and made available for use in various projects. These packages can include libraries, tools, and other software components that are essential for building and deploying applications. By using package feeds, teams can ensure consistency, reliability, and security in their software development lifecycle. Local packages are those that are created and maintained within an organization. These packages are often tailored to meet specific needs and requirements of the organization. By using local packages, teams can ensure that they have control over the quality and security of the software components they use. Additionally, local packages can be versioned and updated as needed, allowing teams to manage dependencies effectively and avoid potential conflicts. Upstream packages are those that are sourced from external repositories, such as public package registries or third-party vendors. These packages can provide valuable functionality and save development time by leveraging existing solutions. However, using upstream packages also comes with risks, such as potential security vulnerabilities and compatibility issues. It is important for teams to carefully evaluate and manage upstream packages to ensure they meet the organization's standards and requirements. Setting up package feeds involves creating and configuring repositories where packages can be stored and accessed. This process typically includes defining the structure of the feed, setting up access controls, and configuring versioning policies. In Azure DevOps, for example, teams can use Azure Artifacts to create and manage package feeds. Azure Artifacts supports multiple package types, including NuGet, NPM, Maven, and Python, making it a versatile solution for managing dependencies. Effective version management is critical for maintaining the stability and reliability of software projects. Teams need to establish versioning policies that define how packages are versioned and updated. Semantic versioning is a common approach, where version numbers indicate the level of changes, e.g. major, minor, patch. By following consistent versioning practices, teams can ensure that dependencies are managed effectively and that updates do not introduce unexpected issues. Access controls are essential for securing package feeds and ensuring that only authorized users can access and modify packages. This involves setting up permissions and roles that define who can publish, consume, and manage packages. In Azure DevOps, access controls can be configured at the feed level, allowing teams to enforce security policies and protect their software components. By implementing robust access controls, organizations can prevent unauthorized access and reduce the risk of security breaches. Package views provide a way to organize and filter packages within a feed. By creating views, teams can categorize packages based on criteria such as stability, environment, or project. For example, a team might create separate views for development, testing, and production packages. This allows teams to easily find and use the appropriate packages for their specific needs. In Azure DevOps, package views can be created and managed through the Azure Artifacts interface. Integrating package feeds with build pipelines is essential for automating the process of building, testing, and deploying applications. By configuring build pipelines to consume packages from feeds, teams can ensure that their builds are consistent and reproducible. In Azure DevOps, build pipelines can be configured to use packages from Azure Artifacts, allowing teams to automate the entire build process and reduce manual effort. This integration also helps in identifying and resolving dependency issues early in the development cycle. Automating the publishing of packages is a key aspect of modern DevOps practices. By automating this process, teams can ensure that packages are published consistently and reliably. This typically involves configuring build and release pipelines to automatically publish packages to the appropriate feeds after successful builds. In Azure DevOps, teams can use tasks and scripts to automate the publishing process, ensuring that packages are always up to date and available for use in other projects. Monitoring and auditing packages is crucial for maintaining the security and integrity of software projects. Teams need to track the usage of packages, monitor for vulnerabilities, and ensure compliance with organizational policies. In Azure DevOps, teams can use tools like Azure Monitor and Azure Security Center to monitor package feeds and identify potential issues. Additionally, auditing capabilities allow teams to track changes to packages and ensure that only authorized modifications are made. Managing package dependencies is a complex but essential task in software development. Teams need to ensure that all dependencies are properly resolved and that there are no conflicts between packages. This involves defining dependency management policies, using tools to analyze dependencies, and regularly updating packages to the latest versions. In Azure DevOps, dependency management can be integrated into build and release pipelines, allowing teams to automate the process and reduce the risk of dependency-related issues. To ensure the effective management of packages, teams should follow best practices such as using semantic versioning, implementing access controls, automating publishing, and regularly monitoring packages. Additionally, teams should establish clear policies for evaluating and using upstream packages, ensuring that they meet the organization's standards for security and quality. By following these best practices, teams can improve the reliability, security, and efficiency of their software development processes. Let's explore a case study of a company that successfully implemented package feeds and views in their DevOps processes. The company faced challenges with managing dependencies and ensuring consistency across their projects. By adopting Azure Artifacts and integrating it with their build and release pipelines, they were able to automate the publishing and consumption of packages. This resulted in improved efficiency, reduced manual effort, and enhanced security. The case study highlights the importance of a well-designed package management strategy in achieving DevOps success. In conclusion, designing and implementing package feeds and views is a critical aspect of modern DevOps practices. By effectively managing local and upstream packages, teams can ensure consistency, reliability, and security in their software development lifecycle. The next steps involve applying the concepts and best practices discussed in this presentation to your own projects. Start by setting up package feeds, defining versioning policies, and integrating with your build and release pipelines. Continuously monitor and audit your packages to maintain the integrity of your software projects.